All right, here's what I want you to do in the first box for me. Just draw a line in the first box. Just draw a line in the first box. Let's go, let's go. I can't keep watching that. Let's go. First box, let's draw a line for me. I don't care what slope it has, what it looks like. Let's draw a line. Then draw a second line for me, please. That intersects your first one. Draw a second line anywhere. Now, finally, draw a third line. Actually, before you draw a third line, highlight that point that those two lines intersect at for me. Put a point there at the point of intersection. Now draw a third line that goes through that point of intersection. So all three lines should be going through the same point. All three lines going through the same point. All three lines going through the same point. All good? I do not want to say all three lines going through the same point anymore. I want to say the word that's up there, concurrent. Concurrent. Let's get that in your vocabulary. Concurrent. All right? All three lines going through the same point, those are concurrent lines. Concurrent. And that point that they go through, I'm already up to 2 vocab words. And it's already been 2 minutes. I'm already up to 2. That point that they go through, it's called the point of concurrency. That's the point they go through. One last time. 3 lines going through the same point, concurrent lines. The point they go through, point of concurrency. Any issues? First 2 vocabulary words today. Get them down somewhere later tonight. All right, next box. Here's what I want you to do. I want you to draw a triangle for me right now. A triangle. Inside that box, draw a triangle for me. And now I want you to draw a circle around the triangle, but here's the key. The circle has to touch all 3 vertices. Okay, so that wouldn't cut it. All right, the circle has to touch all 3 vertices for me, please. All right, if it's drawn on the outside, if a figure is drawn on the outside, we say that figure is circumscribed. So the circle is circumscribed around the triangle. All right, whatever figure's on the outside is called circumscribed. All right, what if the figure is on the inside? We call it inscribed. So now what I want you to do is draw a triangle first for me. Now draw a triangle again. And now what I want you to do is to put a circle inside the triangle. So it touches all 3 sides. Put a circle inside your triangle that touches all 3 sides. And now that it's inside, we say the circle is inscribed. And it doesn't have to be a circle. It can be any figure. If it's inside another figure, it's inscribed. If it's outside, it's called circumscribed. Go back up to my diagram here. Is this the triangle, circumscribed or inscribed? The triangle here, circumscribed or inscribed? Let's go. 6, circumscribed or inscribed, the triangle? Inscribed, because it's inside. Inside. In my diagram here, what about the triangle? Is this triangle inscribed or circumscribed down here? 12, inscribed or circumscribed, this triangle? Circumscribed. It's on the outside. Questions? All 3 lines intersect at a point. They're concurrent. And the point they intersect at is called the point of concurrency. Questions? All right, now I'm going to divide you guys up into groups now. Let's see, we got 1, 2, 3, 4, so I'm going to have to combine a group. That's fine. This whole section here, group 1, you guys here, group 2, you guys here, group 3. All right, every group's going to have a job here. It's going to be like a mini project we got to do. We got to create here. First thing I need every group to do is plot triangle ABC on the graph I've given you. Everyone's got a straight edge on them because you're definitely going to need a straight edge later on when we start graphing more. All right, here's what I want. Group 1, you're going to, what point is the midpoint of AC? That's your job, group 1. Group 2, you're going to find the midpoint of BC only. And group 3, you guys are going to find the midpoint of AB for me. All right, what point is the midpoint of each side? Before we do that, so we don't have any chaos here and we don't waste time, anybody remember the midpoint formula? We had a quiz yesterday. I'm not too sure you got through that one. Midpoint formula. Kelsey?
X2 minus X1. No, plus X1 divided by 2.
There you go. I got to add the X's and divide by 2, and then I'm going to do the same thing for the Y's. Add them and divide by 2. All right, so go ahead. Let's go. In your group, make sure you guys all agree. Find only your side. Your side. So group 1, group 2, group 3. Find the midpoint of your side, please. Group 1. What'd you get? And everyone else is going to copy this down too, please. If everyone else is going to copy this down. Group 1. What do we get for the midpoint of AC? Midpoint of AC, 4-1. Everyone agrees? 4-1. Okay, everybody call that point E for me. So everyone jot down in group 1, point E is 4-1. Then go over to your graph and graph point E, please. 4-1. Group 2, how about the midpoint of BC? Midpoint of BC? 8-2. Good. Everybody call that point F in your chart. Point F, midpoint of BC, group 2, 8-2. And graph it. And graph it. And group 3, midpoint of AB? 5-4. Call that point G, everybody. Point G. 5-4. And graph it. Please do not connect them, just graph them. And we're going somewhere with this. All right, next job for you and your group. You found the midpoints of each of the sides. Now find the slope of your side, please. Slope of your side. So there's two ways you could do this. You could look on the graph and do rise over run. Or you could take your coordinates and do change in y over change in x. It's up to you what you want to do, whatever's easy in your group. Find your slope only. Your slope only. Do not do anything else in the chart. Go ahead. So you can count up and over, rise over run, or you can do change in y over change in x. Go ahead. Find the slope of your line. All right, fill in your chart for me. Fill in your chart. Fill in your chart. All right, group one. What did you find the slope of AC was? AC.
Negative 2/3.
Negative 2/3 looks good to me. Group two, how about the slope of BC? BC? 1/3. One third. BC. 1, 2, 3, 4, 5, 6 over 2. Rise over run. Or if you do, did you do the coordinates too?
Yeah.
What'd you do for the coordinates?
7 minus 9.
Okay, whoa. What's 7 and 9? X or Y's?
Oh, X.
Right? So I think we want to flip it and say it's what? 3 over 1, right? 3. And then group 3, AB, slope of AB? 1/4. Okay, everyone got the slopes written down, all set? All right, here's what I want to do now. I want to draw, we're going to graph a line for each side that's perpendicular to each side. So let's start with AC. I want to draw in a line that goes through point E, but is also perpendicular to AC. Graphing a line that goes through E and perpendicular to AC. Yesterday, you guys had a quiz on quarter one. What do you guys know about two lines that are perpendicular? Slopes are? Slopes are? Woohoo! Uh-oh, here we go. 13 slopes are? Negative reciprocals. Perfect. So if my slope here is negative 2/3, what's the negative reciprocal of that? Flip it and change the sign. It'll be what? 4? 3 over 2. So everyone go to the midpoint, point E. Everyone go to point E with me right now. We're going to go up 3 over 2. So from point E, up 3, 1, 2, 3 over 2. 1, 2, 3 over 2. Grab your straight edge. Line up point E and that point you just graphed. Draw that line through. All good. All right, before we move on, I want to give a name to this line. All right, I want to give a name to this line. 1, 2, 3 over 2. Yeah, I'm good. What do you know about these two lines? Why doesn't my line look perpendicular at all? Did I graph point E right? 1, 2, 3, 4, 1. Yeah, that's right. Up 3 over 2. Does that look all right? Just doesn't look like it's perpendicular to me, does it? All right, I'm going with it. I want to give a name to this line, a vocabulary name. What do you know about the line we just drew in an AC? Those two lines are what? They're perpendicular to each other. They're perpendicular, and it goes through E, which is a what? All right, that's fine. All right. I'll have a staring contest too. 12. What's point E again? That's the what of AC? The midpoint. So this line is perpendicular and goes through the midpoint. Can we have a name for this? Anna, go ahead. It's bisector and it's perpendicular. Put them together. This is a... Okay. 7. Put them together. That's a what? Okay, thank you. 1. This is a what? I'm just asking you to put the two vocabulary terms together. This line is perpendicular to AC and bisects AC. Put them together. This is a what? Okay, Ray. It's perpendicular to AC and bisects it. That's all I'm looking for. This is a perpendicular bisector, everyone. Good? All right, and that's what we're going to do for the other two sides right now. Draw the perpendicular bisector for the other two sides. So let's go to BC now. If BC has a slope of 3, its perpendicular line will have a slope of 11. Negative 1/3. Perfect. Everyone go to point F now. Point F. Where do I go to graph another point now? Negative 1/3. Where do you guys want to go? From point F, go where if the slope's got to be negative 1/3? I'm going to go rise over run first, right? So I got to go up or down. Okay, down 1. Ooh, I don't want to go left, then it's going to be positive. If you're going to go down, you got to go down 1, right 3, or you can go up 1, left 3. All right, you choose, but it's got to have a negative slope. So I'll go down 1, 1, 2, 3, right 3. There you go. Grab your straight edge. One more to go. And you'll notice something about these perpendicular bisectors. Let's do it for side AB. If side AB has a slope of 1/4, what about the perpendicular line? 11 again. It'll have a slope of negative 4. All right, everyone, travel over with me to point G. Where can I go from point G? If I need a slope of negative 4, you tell me. Where should I go? Let's hear from 8. Where should I go from point G if I got to have a slope of negative 4?
Down 4 over 1 to the right.
1, 2, 3, 4 to the right 1, or you guys can go up 4 to the left 1. Your call. Line that up with, yeah, we were correct to begin with. Line that up with point G. What do you see about all 3 perpendicular bisectors? Look on your graph right now. What can you tell me an observation about all 3 of those perpendicular bisectors? 6? Okay, they all intersect. I want to get better than that, though. We have a word, Nate. We have a word. They all intersect. They're all, there you go, concurrent. Everyone see that? They're all concurrent. So conclusions. You guys have a little spot to write a conclusion. Are these lines concurrent? Darn right they are. Yes. And the conclusion, in a triangle, all three, what did we just graph? What are all three of those called again? 7. What are all three of those lines called again? 1. And what are all three lines called again? All three perpendicular bisectors are, Nate, concurrent. They all intersect at the same point. All right, you ready for a name for that point now? That point, are they all intersecting on your graph, most of you? Yes? All right, what's this bad boy called now? Where all the perpendicular bisectors intersect? That point is called the circumcenter. Okay? The point where all three angle bisectors meet in a triangle is called the circumcenter. And that's the only thing we're going to go over today, but it's a lot of vocab already. If you have three perpendicular bisectors in a triangle, they will always intersect at a point that we call the circumcenter. Questions? Because I got one more thing about the circumcenter. All right, what's so great about it? You guys have to know a special fact for me about the circumcenter. Actually, you know what? Go back to your graph. Go back to the graph we just did. Take your compass for me real quick. Put the compass point on the circumcenter that we just found. And what I want you to do is open up your compass to one of the vertices of the triangle that we graphed. Open it up to one of the vertices. Now put your pencil point on another vertice. Did any of you have to change the opening of your compass? Hope you didn't, did you? Go to the third point. Anybody, at any time, did you have to open or close your compass? You kept it the same opening, everybody? From the point from the circumcenter to a vertice? It was the same distance every time, right? Is everybody seeing that? It's the same distance, and that is the special fact about the circumcenter, that it is always equidistant from the vertices. All right? The circumcenter of a triangle is the same distance away from all three vertices every single time. So on the diagram right here, make a little note for me. Point O is the circumcenter. Okay, point O is the circumcenter. And what I want you guys to do is, from point O for me, draw in a dashed line to A, draw in a dashed line to B, and draw in a dashed line to vertex C. What three line segments are now congruent? O is equidistant from the vertices because it's the circumcenter. So that tells me OA, OC, and OB are all the same length. Circumcenters are equidistant from your vertices. Questions? Because we're going to get a little tougher here with the next question. All right, let's jump right into this next one. Here's our triangle. Find the circumcenter. Where is the circumcenter on here? All right, this is going to be brutal the first couple days. Find the circumcenter. Look back if you need to. That's where all three what should be intersecting. The circumcenter is the point where all three blank intersect each other. 12?
Midpoints.
What's that?
Midpoints.
Oh, look, what were those lines called that we drew? I don't know if I can get it back up. What were those lines that we drew? Perpendicular bisectors, right? That's where three perpendicular bisectors intersect. So that's what we need to do for this triangle. Where are the perpendicular bisectors so I can see the point that they intersect? Let's go to side AB. Side AB. Can you guys count for me how long side AB is? Because I'm going to have to bisect it. All right. No, I don't need the distance formula. Can everyone just figure out how long AB is for me? 10 when you're ready. How long is AB? 8 units. So if I'm going to bisect it, it's going to go through how many units away? It's 8 units long, 11 if I'm going to bisect it, 4 on each side. And it's got to be perpendicular to AB. What type of line is AB right here? Here we go, 11 again. What type of line is AB going like this? Straight angle, looking for vertical or horizontal?
Oh, vertical.
It's vertical. And what's always going to be perpendicular to vertical? Horizontal. Can you guys graph that line in for me? That's going to cut AB in half and be perpendicular to AB. Go ahead, use your straight edge. You don't need anything fancy here. Right there. There's the perpendicular bisector for AB. Bisects it, cutting it right in half and perpendicular to it. Is there another side that's pretty easy too? What side's going to be just as easy as that one? BC, go ahead. Do the perpendicular bisector for BC now. What's the only side we haven't done a perpendicular bisector for? AC, right? That's going to be a little bit tougher. Do we even need to do it? Do we need to do the perpendicular bisector of AC, or would we already know where all three would intersect already? Does everyone see what I'm talking about there? Why waste our time? Why are we going to waste our time doing it for AC when I already know where all three of those lines are going to intersect? It's going to be where those two already do. Everyone see that? There's no reason to go do AC. No reason. Because I already know if these two intersect right here, the third one's going to intersect there too. So we have found our circumcenter. We just have to figure out the coordinates. What are the coordinates of my circumcenter? Four. What are the coordinates of that circumcenter? Make sure you start at the origin, not point B.
5.
Yep.
5.
Got it. If you're asked to find the circumcenter, perpendicular bisectors. All right. Any questions? All right, another one here coming up. Let's take a journey into my kitchen. In my kitchen, I got a stove, sink, and refrigerator, and I'm going to remodel my kitchen. I'm going to put an island, not like the sand type, but you know what I'm talking about, right? The old, I don't know how to describe it. The thing in the middle. But here's the key there, kids. I need help. Your help remodeling it. wherever I put the island, it has to be the same distance away from the sink, fridge, and stove. So I don't want to put my island right here. I don't want to put it down here. I don't want to put it up here, right? I want to put it directly in between all three of them. All right, wait a sec. My sink, stove, and refrigerator, if I connect them, are going to form a what? Yeah, triangle. So why don't we do that? Why don't we start right there first? Let's connect all three, two appliances in the sink. And I want to put the island so it's in the center of those. Anybody got another name for the island? A geometric name for my island here? The island's going to be the what of the triangle. What do we call the point that's equal distant away from the three vertices? 9, the point that's equal distant away from all three vertices. That's the circumcenter. Yep. So here we go. Circumcenter. So we need to find the circumcenter of this triangle. Let's keep going with what we've talked about today. Oh, you want me to find the circumcenter? You're going to have to show me what? All three, 5. Locate all three what? Yep. That's what I need your help with, kids. Where are the perpendicular bisectors? Ooh, how are we going to do that? This isn't graphing now. How are we going to do the perpendicular bisectors without a graph? You know how to do it already using your compass and straight edge. This is our most famous construction. Let's start with side KR. How do I find the perpendicular bisector of KR using my compass? Anybody remember this one, the old fish? Put your compass on K or R, doesn't matter. Open it up more than half the distance of KR. And I need about a half circle size arc. We're going to the other side. Keep your compass the same opening. Quick reminder, how many points of intersection should I end up with before I line it up? 2. Hey, that right there is not good enough. That's not good enough. I got to keep going till I get a second point of intersection up top. And then you can line up your straight edge. And this right here is the perpendicular bisector of KR. Perpendicular bisector, KR. What side do you want to do next? Your call. RS, you got it. Let's do RS next. Same exact construction, just on a different side. So I'm going to go to point R or S, open it up more than half the length. Good size arc here. I know your diagram's getting messy. I get it. Go over to the other side. Make sure you have 2 points of intersection. I just totally blew that one. There we go. A lot of arc marks, huh? Whoa, don't go to KS yet. Let's talk about working smarter, not harder. Is there a need to go to KS? Remember our previous problem on the graph? We didn't need to do the third one. We already know where it's going to be. It's going to be, if we did this correctly, it's going to be where the first two intersect. You can do the third one, but we know it's going to intersect right here. So why don't we just stop? We're pretty confident in our ability, I think. So here's where I should put the island. So it's equal distant away from the other three. Is everyone sure you're okay with why I'm not doing the third side? It's going to intersect at that point anyway, if we've done this correctly. Questions? All right, I'm going to do the first homework problem with you. Actually, do you have another? No, you don't. I'm going to do the first homework problem with you just to make sure you're good to go with the rest of it tonight. Because this one is a little bit different than what we've been doing. All right, you can go ahead and read through the directions real quick. All right, big thing right off the bat, I got to ask somebody. The perpendicular bisectors meet at point G. They all meet at point G, so that should tell us from today's discussion, what do you know about point G? G is it's got a name now. If G is where the perpendicular bisectors all intersect, G is what now? Point G is the 6? Good. Right? I don't need to tell you that in the directions. All I need to tell you is those are perpendicular bisectors that meet at G. So G is the circumcenter. Look back in your notes if you have to. I'm sorry. Look back in your notes. What do we know about the circumcenter? What is the one fact I'm asking you guys to remember about the circumcenter? 13, the one fact about the circumcenter. It is?
It's the equal distance away.
From what?
Each perpendicular bisector.
It is equal distance away just from... What are the points called on the triangle?
The concurrent line.
It's equidistant away from A, B, and C, which are the vertices of the triangle. Okay, good, Charlie. Everybody else? It's equidistant from the vertices. So I asked that because I want you to name 3 line segments up here that are now congruent. If G is the circumcenter, it's equidistant from the 3 vertices. Name 3 line segments up here that you know are congruent. Here we go. Redemption, Charlie.
FA, FB, and FC.
Oh, what's the circumcenter? F's not the...
G.
Okay, ready? So GA, keep going.
GB.
GB and
GC.
GC. We know that because G is a circumcenter. Power you have right there. All right, are we all ready now? All right, what's the length of AG now? The length of AG. Look at all the other numbers I've given you on the diagram. What is the length of AG then? 7, length of AG. Stealing my thunder here. Think I would remember. 3. 20. Why do you say 24?
25.
Why 25?
Because GC is equal to GA.
Correct. If that's a circumcenter, G to C is the same length as G to A. 25. Yeah. BD. Now we get a little tougher now. BD. I'll help somebody with this one. BD. 9. Who's got 9? Okay, ready? BD. What is FD in this diagram? If it meets at G, GD. That's a what in the diagram if it meets at G? Perpendicular bisector, right? Perpendicular, say that second word again. So it bisects the side it's drawn to. So what's BD have to be then? Done, 20, because that's a perpendicular bisector. Great work. How about CF now? Let's keep this train rolling. CF, 6, 24. Again, perpendicular bisector GF, that's 24. What do we got? BG. Ooh, how about BG? 7, BG. No, not going to do it. Zip it, Rachel. 4. 25. It's equal distant away. Good. We're almost there. How much time we got left? Oh, perfect. CE now. CE. 6. 15. It's a perpendicular bisector. And what's the last one? AC. Where's AC? Okay, AC, can we add? Yeah? 6 again? 48. All right, so you have 3 problems left now. 3 problems left for tonight. Quizlet index cards, start writing them down. I got more for you tomorrow. Have a good day.